How can we find the net electric force of attraction or repulsion on a particular charge if a system of charge is arranged in a regular pattern? In this video, we are going to focus on that, and we are going to go over plenty of practice problems that will enable you to be very vigilant and intact in this topic. So let's begin with what you need to know. Now you need to know what we call the net force. We denote the net force with either summation of F or F sub n, and it's typically the sum of all the electric force that is applied on a particular charge. Now, how can we find this net electric force? You need to know that when you observe that the system of electric force that is applied on a particular charge are parallel to each other, then F sub net in this case will be indeed equals to the sum of those forces. Let's say the first force is F sub A, just add it to F sub B. Now, another case in which you can have those forces is that you can have them to be perpendicular to each other. Typically, when they will look something like this. In a case whereby they tend to make an angle of 90 degrees with each other, such that they are perpendicular with one another, then to find the net force, all we need to use is to use Pythagoras theorem. The theorem says that the square of the net force is indeed equals to the sum of the square of those other two forces. Now, the next case is what if those forces tend to make an angle with each other and not 90 degrees? In a case like this, we need to head right on to trigonometry and use one of its properties, and that is typically what we know as cosine rule. So if those two forces, for instance, tends to make an angle with each other, let's say alpha, then in a case like this, the net force F sub n will be indeed equals to the sum of the square of those two forces. Let's say this is F sub A and this is F sub B. So that's F sub A squared plus F sub B squared. The minus 2 times F sub A times F sub B multiplied by cosine of angle theta. Theta is the exterior angle between those two forces. So you produce this, the one horizontally, you produce the force horizontally, you produce it towards the left in order to get the exterior angle. So this is theta. To get theta, you can just use some of the geometric properties, typically the sum of angle on a straight line. It knows that the sum of alpha and theta will be indeed equals to 180 as supposed. Then you just need to solve for theta and you plug it in. Kindly note that there's square here as well. So you just need to find the square root of your result that you have here to have the net force. So these are the basic things you need to know about finding the net force of system of charges being arranged in a regular pattern. So let's begin with problems and see how all this concept works. Number one, calculate the net force on charge Q1 in the system below. This is charge Q1, and we have some other charges that follows it. So we want to know all the net force or all the forces that will be applied or that will exert on Q1. First, you need to know how to represent these forces. Let's take, for instance, how can I represent the force that will be exerted on charge Q1 due to charge Q2? How can I represent that? To represent this, here's what you need to do, and that is simply F sub 2, 1, and this can be read as the electric force of charge 2 on charge 1. The electric force of charge 2 on charge 1. Perfect. Now, what about that of charge 3 and charge 1? Because charge 3 will also have effect on charge 1. And that will be what? Exactly. That will be F sub 3, 1. Read as F, or the electric force of charge 3 uncharged one. Good. Now, how can we calculate all this electric force? If you haven't checked my video on Coulomb's law, then I will recommend you consider checking it out. Or you just click on the video that just pop out on the top right hand corner over there. So in that video, I explained everything you need to know and the basic idea behind Coulomb's law. So according to Coulomb's law, to get the electric force, that's simply the constant of proportionality multiplied by those two charges respectively. So Q2 times Q1 all divided by R squared, where R is the distance between those two charges. Similarly, for F sub 3, 1, that will be K multiplied by Q3 times Q1, then all divided by R squared. So at this point, I would like to substitute. Keep in mind, the value of K is a constant value and is about 9.0 times 10 to the power of 9 Newton meter squared per coulomb squared, and that is the value of K. Now, let's begin the substitution. So I'm going to have F sub 2, 1 to be now equals to 9.0 times 10 to the power of 9, then multiply by Q2. Q2 is indeed equals to 5 times 10 to the power of negative 6. Keep in mind, where did I see negative 6? That is the conversion of microcoulombs into coulombs. Okay, that's why I said to consider checking out the video. I explained everything there. Now, what about Q1? Q1 is 2 microcoulombs. I need to multiply it with 10 to the power of negative 6. Okay, so this is Q1 and not Q2. So I'm going to divide everything by R squared. So the distance between Q1 and Q2 is 8, and it is measured in centimeter. But before we use it, we need to turn it to meter. And to do that, we need to divide it by 100, which will become 0.08 all squared. So what about F sub 3, 1? So let's also substitute the respective quantities that we have in F sub 3, 1. So K, I suppose, 9.0 times 10 to the power of 9. Then multiply by Q3, that's 2. This is Q3, that's 2 microcoulombs, that's 2 times 10 to the power of negative 6. Then what about Q1? That's 2 as well. That's 2 times 10 to the power of negative 6. Then everything will be divided by R squared. So what is the distance between Q1 and Q3? The distance between Q1 and Q3 turns out to be 12 centimeter. And since it is measured in centimeter, we need to convert it to meter as we did over here. And all we need to do is just to divide it by 100 and have 0.12 all squared. Some of you might be wondering that why do we use 12? Why don't we use 8 plus 12 as 20? The reason is because um, within Q1 and Q3, there is another charge in between them, which implies that Q2 will have effect on Q1 before Q3. Before Q3 can have effect on Q1, Q1 must have gotten to the position of Q2. So which makes it to what? To have a distance of 12 centimeter between it and Q3 before Q3 can have effect on it. So that is why we need to use 8 centimeter, 12 centimeter. So now let's type this into our calculator and have our answers respectively. If you type everything correctly, you should have F sub 2, 1 to be equals to 14.0625, and for the other one, you should have it to be equals to 2.5 Newton. Make sure you attach the unit with it. The unit of force is Newton. Now that we have the two forces that is exact on Q1, we can now find the net force. So the net force, F sub n, or the summation of F, since those two forces tends to be parallel to each other, then we need to sum them up. I said it earlier. So that would be F sub 2, 1 plus F sub 3, 1, because they are both parallel to each other. But first, let's see if there's going to be any changes in sign within those two forces. Now, what kind of force are we having between Q1 and Q2? Is it a force that will propel Q1 towards Q2 or a force that will push Q1 away from Q2? Since Q1 is positively charged and Q2 is negatively charged, and we know that opposite charge will tend to attract each other. It means Q1 will feel a force that will propel it towards Q2. It will feel a force that will attract it towards Q2. And with that, we can conclude that F sub 2 comma 1 is directed towards the positive x-axis and is going to carry a positive sign. Perfect. So there's no any change in sign on F sub 2 comma 1. Now the second one, F sub 3 comma 1. F sub 3 comma 1, what kind of sign are we going to assign to it? And also at the same time, where will it be directed to? Since Q3 is positively charged and Q1 also have similar charge, therefore they are going to repel each other, as we know that like charges will always tend to repel each other, which implies that Q1 will feel a force that will push it away from Q3. And with that, we can conclude that F sub 3 comma 1 is directed towards the negative x-axis, which will make it to carry a negative sign. And therefore, we need to assign negative sign to 2.5 we have here. And therefore, the final answer as the net force will become 14.02625 then minus 2.5. And that will be indeed equals to 11.5625 Newton. And this is the final solution to this problem. Number 2. Three charges Q1 equals to negative microcoulombs, Q2 equals to positive 3 microcoulombs, and Q3 equals to negative or positive 2 microcoulombs are located at the vertices of an equilateral triangle of side 40 cm as shown in the diagram beside. Calculate the net force on charge Q3 due to the other two charges, given that the charges are placed in the medium of relative permittivity of 2.5. So like we did for the first problem, let's identify all the system of forces that will be exert on Q3. So first, we need F sub 1, comma 3. And secondly, we need F sub 2, comma 3. Because this will have effect on Q3. Similarly, this will have effect on Q3. Now, where will these two forces, where will they be directed to? Also, what sign should we assign to them? Since Q1 is negatively charged and Q3 is positively charged, it means they will tend to attract each other, which implies that Q3 will feel a force of attraction towards Q1, and therefore F sub 1, comma 3 will be directed towards the positive y-axis, and with that, it will carry a positive sign. Now, what about F sub 2, comma 3? This is the second charge, and this is the third charge. We can see clearly that they are similar in charge. They are both positively charged, and with that, they will tend to repel each other, which implies that Q3 will feel a force that will push it away from Q2, and therefore that force will be directed towards the positive x-axis, and which will make it to carry a positive sign. Good. Now, having done that, earlier we said the value of K is equals to 9.0 times 10 to the power of 9 Newton meter squared per coulomb. But I must disclose to you, for this problem, we can't use this value as K. Why? Because this value is used when the charges are situated in a vacuum. But in this problem, they make it known to us that those charges are placed in a medium, and that medium has a relative permittivity of 2.5. So which implies that we need to do some arrangements. So what is the relationship between epsilon sub r and epsilon sub a divided by epsilon sub o? Epsilon sub r means the relative permittivity of a certain medium, and epsilon sub a means the exact or absolute permittivity of that medium, and epsilon sub o or epsilon naught means the permittivity of free space. So which implies that we will need to solve for epsilon sub a in order to get the value of k to use in this problem. So it is observed that if I should cross multiply, epsilon sub a will be indeed equals to epsilon sub r times epsilon sub o. Epsilon sub o is a constant value that is about 8.85 times 10 to the power of negative 12 Coulomb squared per Newton meter squared. And that is the value of epsilon sub o. Now, let's begin the substitution, which implies that epsilon sub a will now be indeed equals to 2.5 as given as epsilon sub r, meaning that the relative permittivity of the medium multiplied by 8.85 times 10 to the power of negative 12. And I'm going to type that into my calculator and have the result. And that should be equals to what? 2.21 times 10 raised to the power of minus 11. And this is the value of epsilon sub a. Here. So it's going to be measured in Coulomb squared per Newton meter square as well. Now, having gotten this, I can now get the value of K that I need to find the electric force that is exact on Q3. So K is indeed equals to 1 over 4 pi E naught. That is for charges that are situated in a vacuum. But since the charges are situated in a medium, we need to use the value of E naught as E sub A instead. So it's going to become 1 over 4 pi E sub A, and that will turn to 1 over 4 pi times 2.21 times 10 to the power of 11. And I'm going to type that into my calculator as well and see what is going to turn out to. And that is indeed equals to 3.6 times 10 to the power of 9. So this is the value of k I'm going to use for this problem. So please, what I will just suggest is that you should be very careful with problems involving system of charges. Make sure you are using the right value of k. Make sure you observe, check the problem very well. If those charges are situated in a vacuum or in any other places aside vacuum. When they are situated in another places aside vacuum, then you will need to do the same process I just did earlier. Okay, you get the absolute permittivity of that medium that those charges are situated, and you use the absolute permittivity to get the k to use in that problem. Okay, because you will always be given the relative permittivity of the medium at which those charges are situated. So let's continue. So right now we need to get rid of this in order to solve for the electric forces respectively. So we have that to be 3.6. Don't forget, I'm going to write that here so you can always record it as soon as possible. That's 3.6 times 10 to the power of 9. So it's now be Newton meter squared per Coulomb squared. Good. Now, F sub 1 comma 3 will be equals to K Q1 Q3 all divided by R squared. And F sub 2 comma 3 will also be equals to K Q2 Q3 all divided by R squared. So By substituting those values respectively, I should have 3.6 times 10 to the power of 9. Then multiplied by Q1 is indeed equals to 2 microcoulombs. That's times 2 times 10 to the power of negative 6. Then multiplied by Q3 is indeed equals to 3 microcoulombs. I have that to be 3 times 10 to the power of negative 6. I'm going to divide everything with the distance between Q1 and Q2. The distance turns out to be 40 as it is given in the problem as this, and tends to be measured in centimeter. So we need to convert it to meter by just dividing it by 100, and that will be 0.4 squared. So let me substitute all the necessary quantities for f sub 2, 3 as well before we begin to type that into our calculator. So k, I suppose, is 3.6 times 10 to the power of 9. Then multiply by the value of Q2, that is given as 3 microcoulombs. That's 3 times 10 to the power of negative 6. Then multiply by Q3 is also 3 microcoulombs. That will be 3 times 10 to the power of negative 6. Then everything divided by r squared. So that's the 0.4 r squared. Now, I can now begin to type that into my calculator respectively. So I got f sub 1, 3 to be equals to 0.135, and I got f sub 2, 3 to be equals to 0.2025. I usually used to be very careful when typing scientific notation numbers into a calculator, as there can always be a mistake. Sometimes my memory might fail me. So if you type that into your calculator and you got something different, you can always let us know in the comment section below. So right now I have all the forces I need to calculate the net force. So I will need to get rid of those forces in order to have enough space. So just jot those forces down as we'll be needing them to find the net force. Okay. So we know that the net force F sub n squared will be equals to F sub 1, 3 squared plus F sub 2, 3 squared minus 2 F sub 1, 3, then times F sub 2, 3, then multiply by the cosine of angle theta. You might be wondering that why am I using this to find the net force? But I said it at the beginning of this video that if those two forces tends to mix an angle with each other, then this will be their net force. Why did they make an angle with each other? You can see that f sub 1, 3 is directed towards this direction, and f sub 2, 3 is directed towards the direction. We'll observe that if we bring those vectors out, those forces, then it tends to look like this, where this is f sub 1, 3, sorry, f sub 2, 3 rather, and this is f sub 1, 3. So they will have an angle with each other, and that angle is going to be 60 degrees. So how did I get 60 degrees? It's according to the problem. The problem makes it known to me that that triangle is an equilateral triangle. And for an equilateral triangle, all the angles within it are going to be 60, 60, 60. So that's where I got the 60 from. Okay. So like I said at the beginning of the video, we need the exterior angle, which is the value of theta. So we need this angle to find the net force. And that angle is going to be equals to 180 minus 60 as sum of angle on a straight line. Okay, so that's going to be equals to 120 degrees. So I'm using theta as 120 degrees. So let me begin the substitution and see what will be our value of net force. So f sub n squared will now be equals to f sub 1, 3. We got that to be 0.135, 0.135 squared plus f sub 2, 3, that's 0.2025 squared, the minus 2 times 0.135 times 0.0225 Okay, my bad. 0.2025, then multiply by the cosine of 120 degrees. So let's type that into our calculator respectively. S of n squared will now be equals to 0.135 squared. That should be what? So that's 0.0182 plus. What about 0.2025 squared? That's 0.041. Then minus 2 times 0.135, 2 times 0.2025. That is 0.0546. Then multiply by the cosine of 120. And I'm going to type everything into my calculator once and for all, and have s of n squared to be equals to. If you type that correctly, you should have the square of the net force to be equals to 0.0865. Then what we're going to do next is just to take the square root of both sides in order to have our final answer. And boom, we have f sub n to be indeed equals to plus or minus the square root of 0.0865. And if I take the square root of that, then I will get the net force to be 0.2941 meter. And this is the final answer to this problem as well. By now, you should have been getting familiar with problems involving system of charges. Number 3, 4-point charges are at the corners of a square of side A as shown below. Determine the magnitude and direction of the resultant electric force on Q in terms of K, Q, and A. By the way, if you haven't subscribed to my channel, please do well to subscribe, and don't forget to give this video a like, as that is what inspired me and what we tell YouTube that the video is loved to watch in order to recommend it to many other viewers outside there. So let's begin by listing out all the forces that will be applied on charge Q. This is our main goal. So first, let's assume this is Q1. Okay, this is Q2, this is Q3, then this is Q4. So what will be the F? Okay, let me shift that into bit. What will be F sub 1, 2? The electric force of charge 1 on charge 2. Also, what will be F sub 3, 2? The electric force of charge 3 on charge 2. And lastly, a question I would like to ask you is, will the fourth charge have an effect on the second charge? What do you think? The answer is absolutely yes. Charge 4 will always have an effect on charge 2. And how is that possible? By the diagonal of the square. And that's it. So therefore, we need the third electric force, which is F of 4, 2. So let's know where those forces are going to be directed to. So the first force, that's F sub 1, 2. Where will it be directed to? Which sign should we assign to it? Since they are both similar in charge, as you can see, they are both positively charged. It means Q2 or Q sub 2 will feel a force that will push it away from Q1, and therefore it should be directed towards the positive x-axis this way. We are still going to draw its vector diagram, but for now, let's assign all the value. And with that, it will be carrying a positive sign. Let me just put it there. Now, what about f sub 3, comma 2. This is 3. Okay, my bad. This is f sub 3. This is 3, the third charge, and this is the second charge. So now, since they are both similar in charge, just like that of the first charge, then it means Q2 will also feel a force that will push it away from Q3, and that will be headed towards the positive y-axis this way. Let me use different color so that you can always identify it properly. And with that, it will carry a positive sign. Yeah. Now, what about f sub 4, comma 2? That is this charge and this one. Now, it is noticed that they are both also similar in charge. They both carry positively charged. It means this Q2 will feel a force that will push it away from Q4. And with that, it will be directed towards this direction, which is still the same as positive side of the x-axis, of the y-axis rather. Now that we know the direction of those forces, let's draw their vector diagram and see how to find the net force. Now, it is observed that this is Q2, which is the charge that we need all the net force on it, and it's positively charged. So Q1 tends to move this way, and therefore I'm going to have a vector along this direction. Okay. Similarly, Q2, which is this and this, it tends to move this way along the vertical part of the y-axis. So that will move this way. Then lastly, Q4 tends to move this way, and therefore it will move along this direction. So is there any important conclusion that we can draw out in this vector diagram? First, since this and this are perpendicular to each other, we can get their net force, which will move along this direction. And we'll observe that their net force tends to be parallel to this, which is F sub 4, comma 2. Therefore, having gotten the net force between this and this, we can add it to this and have the total net force. And that is how to get the net force of this problem. I believe you grab what I'm trying to do in excess. So let's do that now. So first, we need to get the net force of F sub 1, comma 2. So F sub 1, comma 2 is indeed equals to KQ1. You can see for this problem, it didn't specify any medium. So we assume it is in vacuum. So K, we have to leave the answer like that. Q1 is 2Q. I'm just going to use dot as product. Then Q2 is Q divided by R is A squared. And what about F sub 3, comma 2? That will be K times Q3 multiplied by Q2 all divided by R squared. And that becomes K. The value of Q3 is 2Q. So I have 2Q. Then multiply by, what about Q1? Q1 is Q. Or Q2 rather is Q. So I have it this way. Divided by R is A squared. And the last one is also K times Q4 multiplied by Q2 all divided by R squared. So I have K times Q4 is 3Q. Okay. Then Q2 is 2Q times Q all divided by. Now the question is, will the distance between Q4 and Q2 still be A? The answer is no, it won't be A. We need to find it. So we need to use Pythagoras theorem to get the distance between Q4 and Q2. So we need the distance. Let's assume the distance is x. So x will be indeed equals to, x squared will be equals to a squared plus a squared. And x squared will be equals to 2a squared. And taking the root of both sides, x will be equals to square root of 2a squared, and which returns to a root 2. So this will be a root 2. Good. Now I have everything. Let me find the net force of f sub 1 comma 2 and f sub 3 comma 2. After that, I will now add that to this one, like I said earlier. So that's what we are going to do right away. So hopefully you have written that. So let's find the net force first. So f sub n, since they are perpendicular to each other, we are using Pythagoras theorem. Pythagoras theorem says that the net force, the square of the net force, is equals to the square, typically the sum of the square of other two forces. So which will be equals to the square of k, or let me just multiply once and for all. This should be equals to 2kq squared divided by a squared. So I'm going to replace that. 2kq squared divided by a squared all squared plus, and this will become 2kq squared divided by a squared plus 2kq squared divided by a squared, then all squared. Perfect. So right now I can get rid of this ones. Okay, now I can have the net force squared to be equals to f sub 1 comma 2. We got that to be this, so I'm just going to distribute the squares respectively. So that will be 4k squared q raised to the 4 divided by a raised to the 4. I'm just trying to distribute the square respectively, according to indices laws. So plus 4k q squared q raised to the power 4 all divided by a raised to the power 4. So this is 4. So the next is to find the LCM. So the LCM will still remain a raised to the 4. And I should have it to be equals to 4k squared q raised to the 4 plus 4k squared q raised to the 4. So which is indeed the same as 8k squared q raised to the 4 divided by a raised to the 4. So what I'm going to do next is to take the square root of both sides. Okay, so I'm just going to take the square root of both sides. And I should have f sub n to be equals to the square root of 8k squared q raised to the 4 over a raised to the 4. So the square root can affect k squared, q raised to the 4, and a raised to the 4. And the answer will become square root of 8 multiplied by k multiplied by q squared, all divided by a squared. And this is the net force between f sub 1 comma 2 and f sub 3 comma 2. Now I can now combine this net force with f sub 4 comma 2. Since they are both parallel to each other, I can just find the summation of those forces. So the summation of f will now be equals to f sub n plus f sub 4 comma 2, because they are both heading towards the same direction. As you can see, this one is going this way and this also is going this way. According to the diagram I showed you earlier, both of them are going the same way. And when two vectors are going the same way, this meaning that they are parallel to each other, you can just add them up in order to have the net force. And this will be equals to square root of 8k q squared divided by a squared plus 3k q squared divided by a root 2. Okay, that's a root 2. So what I'm going to do next is to find the LCM. I can now get rid of this. So what will be the LCM between a squared and a root 2? So we need to square this. We haven't squared this. We need to square it. Okay, according to the Coulomb's law, the distance has to be squared. So this should become square root of 8 kq squared divided by a squared plus 3kq squared divided by a squared multiplied by 2. That's 2a squared. Perfect. That's 2a squared. And therefore, the LCM can be 2a squared. And as you have this to be 2 root 8 times kq squared plus 3kq squared. A in 2a, you are left with 2. You multiply it with this. And 2a in 2a, you are left with 1. You multiply with this. So that's how I got that. So what is the value of 2 root 8? So I need to type that into my calculator. So that turns out to be, let me just write it here. Summation of f is now equals to 5.65 kq squared plus 3kq squared divided by 2a squared. So I'm going to add that to 3. So I have 8.66 kq squared divided by 2a squared. And we should have our final answer to be divided by 2. And we have 4.33 kq squared divided by a squared. And this is the final answer to this problem as well. By now, you should have been very intact and perfect in dealing with problems involving system of charges being arranged in a regular pattern. As you can see, all the techniques, just figure out the vector's direction and check how to find out the net force respectively. When those vectors are parallel to each other, you don't need to bother, just add them. When they are perpendicular to each other, use Pythagorean's theorem to get the net force. When they make an angle with each other, you have to use the cosine rule, but you need to use the angle theta, which is 180 minus the angle between those two vectors. And that's how to easily and mentally deal with problems involving system of charges. So let's consider one more for this video. Number 4. Calculate the net force on the charge Q3 in the system of charges below. We have this to be in rectangular form. Okay, so they said we should focus on Q3. So this is charge Q3. So what are the forces that will be applied to it? So first, let's list out those forces. So we are going to have F sub 1, 3. We are going to have F sub 2, 3. And we are going to have F sub 4, 3. So where are they going to be directed to? Let's see. So we are going to draw the vector diagram later. So F sub 1, 3, this is the first charge, and this is the third charge. So they tends to be different in charge. This one is positive charge, and this one is negatively charged. So it means Q3 will feel a force that will push it closer, that will propel it towards Q1, and therefore it's going to be directed towards this direction, and its positive sign towards positive y-axis. Okay. Now, what about that of F sub 2, 3? This is the second charge, and this is the third charge. So we can see that they are both different in charge as well, which implies that Q3 will also feel a force that will propel it towards Q2, and therefore it will be directed towards a negative x-axis and going to carry a negative sign. Now, what about Q4 and Q3? They tend to be similar in charge, which implies that like charges will repel each other, and it will be directed towards the negative y-axis, and it will be directed this way, and it will carry a negative sign. Good. So those are the vectors of those forces that will be applied on Q3 alone. Now let's draw the vector diagram and see how to figure out the net force. Okay. So first, I would like to draw F sub 1, 3. So that one is directed towards this side. Okay. So I'm having a vector this way. So what about F sub 2, 3? That one is directed toward the negative x-axis this way. Okay. So I'm going to have it this way. Then the last one, F sub 4, 3. So that one is directed this way. I'm going to have it this way. Okay. So those are the um, vectors. Those are the forces that we are having. So we need to calculate the net force. So what should we do? So what we are going to do in this case is that since f sub 2, 3 and f sub 4, 3 are perpendicular to each other, we can use the idea we use in the just recent previous problem. We find the net force between them using Pythagoras theorem. Now we'll observe that the net force between them is making an angle with f sub 1, 3. And after getting that angle, we can use cosine rule. Since we are having two vectors making an angle with each other, we can use cosine rule to get their net force. So that's a quick, easy way to identify the net force. So we already know what to do. So first, let's find the net force between f sub 2, 3 and f sub 4, 3. So f sub 2, 3, that will be kq1 or q2, q3 divided by r squared, and f sub 4, 3 will be kq4, q3 divided by r squared. Okay. So the value of k, since the distance specify any medium, we are using that of vacuum. So that's 9.0 times q2. Q2 is 3. Q2 is 3 times q3 is 3 and times 10 to the power of -3. So because of space, I've already worked with those index of 10. Those index, that of k is 9.0 times 10 raised power. Let me write it because of those that might have forgotten. K is 9.0 times 10 raised power 9. That of microcoulombs, that will be 10 raised power minus 12. By the time you add them together, this will be 10 raised power minus 3. You understand? So because of space, I have it this way. Now, what about that of f sub 4, 3? So that should be 9.0 times q4. Q4 is 2. This is q4 times q3 is 3 times 10 raised power minus 3. Then all divided by r squared. So this is 40 centimeter. Okay, distance is 40 centimeter. And for this one, it is 30 centimeter. Okay, then we are going to have this to be divided by 0.4 squared, and this will be divided by 0.3 squared. Okay, hopefully you grab that. Okay, now let's type this into our calculator and see our final answer. So for the sake of those who might be wondering how I got this 10 raised power minus 3, because my mind is still baffling me that some of you might be wondering how this 10 raised power minus 5. This is what I did. This is 9.0. Okay, let me just get rid of f sub 1, 3, since we are not in use of it for now. So this corresponds to 9.0 times 10 raised power 9, then multiply by 3 times 10 raised power minus 6. They are measured in microcoulombs. So we need to multiply them with 3 raised power minus 6. 3 times 10 raised power minus 6, then multiply by 3 times 10 raised power minus 6. Okay, then divided by 0.4 all squared. Now you can see that we can combine all these 10 raised power minus 6 respectively. So we have a product sign between them. So that will be 10 raised power minus 6 minus 6 then plus 9. That should result in 10 raised power minus 3. So that's how I got those 10 raised power minus 3 respectively. So by now I think you should have get that aspect. Good. So let's type that into our calculator and see the result. So if you type that correctly, you should get f sub 2, 3 to be equals to 0.506 and f sub 4, 3 to be equals to 0.6. So having gotten that, we can find the net force between them using Pythagoras theorem. Okay, so the net force between them, f sub n squared, according to Pythagoras theorem, is equals to f sub 2, 3 squared plus f sub 4, 3 squared. So that will be 0.506 squared plus 0.6 squared. So that should be, let's type that into our calculator. 0.506 squared. We have that to be 0.256 plus, what about 0.6 squared? We also have that to be 0.36. And finally, we need to add them up plus 0.256. So that's 0.616. Good. So f sub n squared. So finally, we need to take the square root of both sides in order to have our final answer. So f sub n will now be equals to the square root of 0.616. And we should have that to be equals to square root of 0.616. That's 0.785 Newton. So this is the net force between this red color force and this white color force. That is F sub um, 2,3 and F sub 4,3. I believe we got that. For this yellow color force, that one is for F sub 1,3. So having done that, we can now find the net force between F sub 1,3 and the net force that we have between F sub 2,3 and F sub 4,3. But first, we need this angle. Let's say this angle is alpha and this one is beta. We need those two angles in order to get the angle between those two forces. This one is F sub 1,3 and this one is F sub 4. No, that's the net force. That's the net force between. Okay, let me get rid of this. Okay. Now, since F sub 1,3 and F sub 2,3 are of this form, then the angle between them is going to be 45 degrees. Why? Because this is a rectangle and each angle of a rectangle is 90 degrees. And since f sub 1,3 is a diagonal of the rectangle, then it means it has divided the angle into two equal parts, and this angle is going to be 45 degrees. So that's how I got that 45. So which implies that alpha is 45. So our main goal now is to get beta. So alpha is equals to 45 degrees. Now what about beta? How can we get beta? Now we have the value of f sub 2,3 and we have the value of the net force as well. We can use that to get the value of beta, okay, using some of the trivial identity. So we can see that this one is serving as hypotenuse, this one is serving as adjacent, and if we find this vector, then we observe that it will be serving as the opposite. So let's do that. We just need to find the value of beta. We know that what function connect hypotenuse relative to the angle and the value of adjacent. So that should be cos. So cos beta is equals to adjacent, which is, let me just write it first, divided by hypotenuse. So adjacent is f sub 2,3 and hypotenuse is f sub n that we got here. Okay, hopefully you are with me. Then I should have f sub 2,3, we have that to be equals to 0.506. F sub n, we have that to be 0.785. So if I divide that using my calculator, 0.506 divided by 0.785. So I have 0.644. So I have 0.644. Let me write that here. Okay. So don't forget alpha is 45 degrees. So cos beta is equals to 0.644. 45 for instance. So beta will be the cos inverse of 0.645. So the cos inverse of answer, so beta is 49. So beta is equals to 49 degree. Okay, 49.8 degree. So that's the value of beta. And finally, the value of the angle between those two forces will be beta plus alpha, and that will be 49.8 plus, so the value of alpha is 45, and that should be indeed equals to 49.8 plus 45, that's 94.8. That's 94.8. Perfect. So right now I can now find the total net force. So let me get rid of this and find the total net force. So I just said that gamma as the total angle is 94.8. Okay. Now we know that the net force, total net force, summation of net force squared using Pythagorean the cosine rule is equals to the square of these two forces, f sub 1, 3 squared plus f sub n squared, the minus 2 times f sub 1, 3 times f sub n cosine of angle theta, where theta is 180 minus gamma. I believe you grab that. Okay, so that will be f sub 1, 3. Okay, we haven't find the value of that yet, so let's find that. So we need to do some arrangements. We know that f sub 1, 3 will be equals to kq1 q3 divided by r squared. But the r is the diagonal of the rectangle. To get the diagonal of the rectangle, we need to use Pythagoras theorem. So r is equals to r squared equals the sum of the square of those two sides. That's 0.4 squared plus 0.3 squared. And r should be the square root of 0.4 squared plus 0.3 squared. And that should be indeed equals to what? Let's see. And that is indeed equals to 0.5. That's 0.5. So therefore the value of r is 0.5. So right now I can substitute. So f sub 1, 3 is indeed equals to 9.0 times 10 to the power of 9 times the value of q1, that's 2, times 10 to the power of negative 6, times q3, that's 3, times 10 to the power of negative 6, then divided by 0.5 all squared. Let me type that into my calculator. So if you type that properly, you should have f sub 1, 3 to be equals to 0.216. Okay, should have it to be 0.216 Newton. So I'm going to substitute now. So I have 0.216 squared plus f sub n. We got that to be 0.785 squared minus 2 times 0.216 times 0.785. Okay, then multiply by cosine of 180 minus gamma, which is 94.8. Okay, so I'm going to type that into my calculator once and for all, and have f sub n squared, which is the summation of those forces. And if you type that properly, you should get that to be 0.635. And I'm taking the square root of both sides. I should have f sub n to be indeed equals to the square root of answer, that's 0.7, 0.97. Okay, 0.797 Newton. And this is the net force acting on the object. So hopefully you gain something, and this is how to handle problems involving system of charges. And I believe you find this content helpful. Please, if you haven't subscribed, like I said earlier, please do subscribe to my channel. Thanks for watching. I really appreciate it. See you guys in the next video.